Good morning, everyone. We are going to talk about adding rational terms, subtracting them. Sometimes they will have the same denominator, sometimes they won't. But the key thing here is finding the LCD, least common divisor. And this is something that we talked about last time. So let me start with something simple first. That is 8x minus 5y divided by 2x minus 3x minus 11y over 2x. Now let me double check if this is being recorded. It is, and it's being shared. Alrighty. Okay, so how do we do this? The first thing is that we notice that the least common divisor is 2x. It's exactly the same on both denominators. Okay, so notice that I'm starting with a simple example. So whenever you have that situation, it's the easiest case because you're going to keep the same denominator, 2x, and then you're going to concentrate on solving or combining, I should say, the numerator. Now notice that whenever you have a minus here, it is best to put a parenthesis around here. Why? Because this negative will impact each of these terms. So make sure that you take that extra step. So now what do we have? We have 8x minus 5. Then I'm going to start multiplying this. Negative times positive is negative 3x. Negative times this negative turns into a positive 11y. My denominator is still the same. At this point, all I have to do is combine like terms if possible. So 8x minus 3x is 5x. Then I'm going to write 11y. That was the, actually, this is 5y. Okay. So minus 5y plus 11, that's going to be 6y. Alrighty. So this will be 6y, 6y, not 11. Okay. Over 2x. Again, I'm combining 8x minus 3x gives you 5x minus 5y plus 11 is how I get the 6y, and this will be my final answer. Can I reduce this? And the answer is no. I don't have any common terms that I can simplify further. Okay, this is a simple example where the denominators are exactly the same. Okay, well, what happens when you don't have the same denominator? So let's see what happens there. Okay, so give me 1 second. Here's an example. We have 4b minus 9 over 2b plus 5b minus 1 over 6b. Okay, so this is 6b. Now, this time we don't have the same denominator, so we have to find the LCD. I'm having difficulty writing b. Okay, there it is. So what is the LCD first? Well, it's going to contain a b for sure, but now I need to see which of the numbers I select. I have 2 and 6, so I'm going to do 2. 2 times 1 is 2. And what is 6? 6 equals 2 is 2 times 3. So these guys are exactly the same, so I'm going to choose 2. And then I notice that 3 is a different factor from all of them, and it's also a prime factor as 2 is. And so now my LCD will be, this is 3 actually, will be 6b. Okay, this is my LCD. This is the process in which you find the least common divisor, okay, or multiple. Now that I know that the LCD is 6b, well, I already have 6b here, so this one is ready to go. The one that I need to work with is 2b. How do I make it into a 6b? I already have the b, I have a 2, I need to make it a 6b, so I need to multiply top and bottom by 3. Okay, and when I do that now, I'm going to distribute this here. So that would be 12b minus 27 over 6b plus 5b minus 1 over 6b. So now we're adding two terms with the same denominator, which is exactly what we did first. Okay, so now this will be 12b minus 27. Now I don't need to put a parenthesis on the second term because I have a plus. So this will be plus 5b minus 1. You see? If you go back, the reason why I put a parenthesis around here is because of this minus. And this will affect these terms. But this is a plus, so you don't have to worry about that. Okay? So what is my final answer? It will be 6b. That's my denominator. My goodness, I apologize. This pen, it makes it difficult for me to write the 6b. So here's 6b. And how do I combine the numerator? So I have 12b plus 7 plus 5b. 12 plus 5 will be 17b. Minus 27 minus 1. When you add them, you keep the sign, and it will be negative 28. And that's my final answer. You see? You are combining two terms into a single term. And that in mathematics is very, very useful. In fact, my class that I'm teaching, college algebra, which is the next class that you guys need to take, we're actually doing something similar. Very similar, that in order for them to complete the exercise, first they have to do this step. So make sure that you learn this well, okay? All right, let's do another one where the denominators are not the same. You see? So clearly, the LCD will be the product of these two different prime factors. My LCD will be the product of these two guys. Notice, they differ. X minus 6 is different from x minus 3. So I need a representative from each. Okay. All right, what do I do next? Well, my next step is to make sure that I have the same denominators, which at this point I don't have. So what do I need to do? I need to multiply this top and bottom by whatever it is you're missing. And in this case, I'm missing x minus 6. You see? Now the denominator is exactly as the LCD. The second term, what am I missing here? Well, what am I missing here is x minus 6. No, x minus 3, I'm sorry. X minus 3. So look what I have now. I have a mess. So let's clear this mess a little bit. I'm going to write my denominator. This is going to be my least common denominator. And the numerators, I have to FOIL this carefully, okay? It's a lot of work. So I'm going to end up with x squared plus 7x minus 6x. And negative 6 and 7, when you multiply, that gives you negative 42. And then I do this too. Okay, so be careful with this stuff. It's a lot of writing. Make sure that you don't miss a step. And then at this point, you want to combine like terms. Again, I rewrite the denominator. At this point, it's just rewriting. And now I need to combine like terms. X squared plus another x squared gives me 2 of them. And then I have 7x minus 6x is x. Negative 3x plus x is negative 2x. X minus 2x is negative x. Then I combine the constants. Negative 42 minus 3 is negative 45. And that's it. That's as far as you can go In this case, you're not able to factor anything. And that's as far as you can go, okay? Now, just for practice, what is the domain of this final expression? Well, the domain will be everything but 6 and 3. Where did I get 6 and 3? Well, when you equate the denominators, you get that x cannot be equals to 3 or 6. Okay, so the domain is everything except 6 and 3, or 3 and 6, whichever order you want. Okay. All right, let's do another one. Now let's do one that is what they call a complex fraction. Okay, so let's do this one here. Look at this here. So when you first look at this, it looks difficult, right? But I show you that it will not be difficult. Look at the denominators. What is the LCD? The denominators are basically 4, 1, 1, and 3. So basically you're doing 4 times 3. So I need to pick all different factors. In this case, it's 12. Okay, my LCD is 12. Look what I'm going to do now. This is the easiest way to do this. I'm going to multiply the top one by 12 and the bottom one by 12 also. Now, by doing so, I'm not changing the value of the number. Okay, because whatever the number is, multiplying times 12 over 12, which by the way is 1, it doesn't change the numerical value. But what will happen is that it will look a lot better. So here it is. See? So now I'm going to multiply 9 over 4 times 12. I'm going to simplify that later. 2 times 12. I'm going to simplify that later. 12 times 1 is 12 minus 5 over 3 times 12. Okay. Now what do I have? I can simplify this. Look, if I divide this 4 by 4, I get 1. If I divide the 12 by 4, I get 3. So I get 9 times 3 is 27. Plus 2 times 4, 2 times 12 is 24. Now 12 minus, notice here, this is 3. I can divide this by 3, I get 1. 12 divided by 3, I get 4. 4 negative 5 is negative 12. Okay, so now what do I have? What do I have? Give me 1 second here. I need to erase this. And I'm going to add them. 4 and 7 is 11, carry 1. And 2 and 2 is 4, and this is 51. And then you get negative 8. So the answer will be negative 51 over 8. That is equals to the original fraction that I had. It reduces to that simply. Okay, let's do another one. Let's do this one. 1 minus 4 over x plus 8 over 16 over x plus 8 plus x. So similar to this one, to the previous one, the difference now is that we're using variables. So what is the LCD? Well, the LCD in this case is easy because there's only one of them. There's only a single term, x plus 8. The other denominators is just 1 and 1. So you're not going to write 1 times 1, which is 1. If you insist in doing that, go ahead. It doesn't matter. Okay. So this will be your LCD. So I'm going to do exactly what I did with the previous one, where I multiplied 12 divided by 12. Okay. So I'm going to multiply this top and bottom by 8, x plus 8. And this one too. Okay. here we go. Here, 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 and here. So this is equals to 1 times x plus 8 is x plus 8 minus, this time this denominator cancel this, what's left is just the 4. You see? Now doing x plus 8 at the denominator here, so this cancels. So what I have left is 16 plus then x plus 8 times x. And then you can simplify this. Where did I get this 4 from? 8 minus 4, 4. Now you can write this first, x squared plus 8x, and then we can write the 16 on the tail at the very end. This is the right. Hold on 1 second. Yeah. So that's as far as you can go. Now, can I simplify this? Okay. In this case, maybe I can. Now, how do we factor the denominator? So let me write it here. X plus 4 divided by this. I'm going to factor. Okay, so I get 2 of them. So this cancels now. So what is my final answer? My final answer will be 1 over x plus 4. And you might be saying, where's the 1 coming from? Right here, my friends, right here. This is a 1. Now, this here will remain in the denominator. So make sure you write it there. Don't tell me that the answer is x plus 4 because that's wrong. It's 1 over x plus 4. Why? Because this came from the denominator and it will remain in the denominator. It cannot all of a sudden move to the numerator. That will be wrong. Okay? So that's the reason. This is the answer. For practice, what is the domain here? The domain is all real numbers except -4. Where did I get -4 from? Here. Set the denominator equals to 0. And when you solve for 4, for x, you get -4. This tells you that x cannot be equals to -4 because this isn't the denominator. X plus 4 isn't the denominator. Okay? All right. Now let's do solving equations. This is solving. Excuse me. Solving equations. Okay. Now the difference between solving equations and solving and simplifying, this is the key word, simplifying and solving are not the same thing. Okay. Notice that here I had this ugly thing and I did a bunch of steps and all of this simplified to this. That's not solving. That is simplifying or combining. Okay. This time I'm going to solve an equation. Let me show you what it looks like. This is just one example. Okay, so there it is. Notice that this is the first time that we are dealing with an equation in this topic. Before, you didn't have an equation. You see? The original problem didn't have an equation. This one does. Okay? So before I continue, I want to exclude any problems that may cause down the road. And the values that may cause issues are x equals to -7 and x equals to 2. These values cannot be. No matter what happens, I know that my answer cannot be -7 or 2. Why? Look at the denominator. Okay? So the domain of this solution will be any number except -7 and 2. Why? Again, look at the denominators. Okay. All right. So now, what is my LCD? My LCD will be the product of those two. Okay. That will be the product of those two. Now, because this is a very trivial case, notice that on the left-hand side, you have a single term equals to a single term on the right. Because of that, and that's the only time that you're allowed to do that, we're going to cross multiply. Boy. And this is what I mean by cross multiply. Okay. But again, that can only be done when you have a single term on the left equals to a single term on the right. Otherwise, you cannot cross multiply like that. All right, so let's solve this. I'm going to distribute the -8. Okay. And then I need to solve for x. So I have x's, I have -8x on the left, and on the right I have 10x. I need to be able to move them on one side, and the constants, which is 16 and 70, they need to go to the right. So I need to move some things around. Okay. Alrighty. So notice that the x is here now. Notice that when I move 10x to the other side, to the left side, don't forget to change the sign. Same thing for the positive 16. Don't forget to change the sign. If you do that, if you forget those little basic trivial things, then it's going to be a nightmare. Okay. All right. So this is going to give you what? -18x. And that is 54, correct? So we have 70, take away 16, and it gives you 54. Now, when I divide both sides by -18, how do I get? I get -3. So x is equals to -3. Now, before you claim victory, before you say, oh, I got the answer, check to see if this number here is one of the numbers that were excluded from the beginning. Is it? No. -3 is neither -7 nor 2. So that means that my solution is actually -3. If for some reason you do all this work and you end up with either 2 or -7, then in that case, this problem will have no solution. Why? Because those numbers cannot be a solution to the problem because they will make the problem undefined. So make sure you keep track of these things. Do not jump to conclusions without checking your work, making sure that you find first, make sure that you exclude any issues. Those issues are -7 and 2. Okay. All right, let's do another one. Okay. Let's do another one that is easy. All right. This time, my answer cannot be 0. Look at the denominator. X cannot be 0. Okay. And my LCD is simply X times 1 if it makes you happy. There it is. Cross multiply. Why? Because I have a single term on the left equals to a single term on the right. So I can multiply 2 times, I can multiply x times -8. It gives you -8x equals to times 2. Then I divide this by -8. I reduce. Make sure that you simplify this as much as you can. Notice that your answer here is -1/4. So that is your answer. If for some reason you do all this work and you end up with x equals 0, and from the beginning you said that x cannot be equal to 0, and then in that case, the problem will have no solution. Okay? All right, let's move on. Let's do this one. Let's find first the issue. Y cannot be equals to 4. Why? Look at the denominator. How did it get the 4? Take the denominator, put equal to 0. Solve for x. I mean for y. Here I'm saying I don't want the denominator to be 0. And what number makes it 0? 4. So I don't want that. All right, so now I can cross multiply. 1 times 5 is 5. Sorry, -5 actually. So what do we have? We have 6y minus 24 equals to -5. Okay. Move the -24 to the other side. And I'm going to end up with, what do I end up with? 19. Okay. Divide by 6. And there it is. 19/6. That is my solution, because the only one that was excluded from possible solutions was 4. And clearly 19/6 is not equal to 4. So this is my solution set. It's 19/6. I don't know why I bring that. Hold on one second. This keeps popping up. All right. There it is. Let's do another one. This is how you practice. This is how you learn, by doing and learning this stuff. All right. Let's do 5/3 equals to 4/x minus 1. This time I cannot cross multiply, because even though on the left hand side I have a single term, on my right I have two terms. This is one term and another term. So I cannot do that anymore. Now, what I can do is exclude 0 from my possible solutions. Notice the 3 here. This 3 is a constant. It's not going to affect your solution. Okay? The one that you have to pay attention to is the variable. The variable here is x. So you want to state clearly that x cannot be equal to 0. Now, don't tell me this will make no sense whatsoever. This makes no sense whatsoever. Okay? Some people, I've seen that before. It's like, where do you get that from? Do you think that 3 will become 0 all of a sudden? No, 3 is 3 no matter what. Okay? The variable could become 0. That's why they call variables. They take different values. Okay? Now, what is my LCD? My LCD will be 3x. So now I'm going to multiply everything by 3x. Okay, here I go. I'm going to multiply term by term. So I'm going to have 3x times 5/x. That cancels. What's left is 5x equals to, then I move to the other side. On the other side, I'm going to have 3x times 4/x. This time the x cancels. 4 times 3 is 12. Minus 1 times 3x is just minus 3x. You see, you went from having irrational equation, meaning you have the variables in the denominator. Through this process that I'm teaching you, now you have a linear equation, which is a lot easier to handle. Okay, so now I'm going to move all the x's to one side. This is going to be 8x divided by 12. I mean 12 divided by 8. That's what I meant. You can divide this by half. That will give you 6/4. Continue divided by half, 3 over 2. So the answer is 3/2. Now notice that the only one that could have never been the answer was 0. So clearly, this is a good answer. 3/2 is a good answer. Okay. Now, where did I get the 8 from? 5x plus 3x gives you 8x. Then you divide by x by the 8, 12 divided by 8, and then you reduce it, and you end up with 3/2. Okay. All right. Let's do another one. This will be the last one. Okay. Let's do 6 over 3y minus 18 minus 3 equals to 2 minus, not minus, over y minus 6. So that's what I need to do. Notice that it looks intimidating. What do I do first? One thing that you cannot do is cross multiply because you have 2 terms on the left and 1 term on the right. The only time that you're able to cross multiply is when you have a single term on the left equals to a single term on the right. That's not the case here. All right, so what do we do? First, I notice that I can simplify this. You see that? So what is my LCD? My LCD will be 3 times y minus 6. There it is. You need a 3 because it's different from all others. And you have 2y minus 6 here and here. Then you just choose one of them. Okay. Had this one been an exponent, then you will choose the one with the highest exponent as your LCD. All right. What else do I need to do? Well, I need to make sure that y cannot be equal to 6. See, this is the preliminary work that I need to do to make sure that I don't make a mistake at the end. All right, what do I do next? Next, I'm going to multiply this by my LCD. Gee, where do I write it? I don't have space. Oh boy. Oh boy. So here it is. It's going to look very crowded. Okay. In fact, let me do it here so that you guys can see. Here's my LCD. Doesn't matter which way you put it. You can put it on the right, on the top of the right, or the top of the left. It doesn't matter. Then I need to multiply this, this, and this. All right. Notice that when I multiply this term, and this term cancels. So what's left? 6 minus. This 3 is a numerator. So 3 and 3 gives you -9 times y minus 6 equals to, what cancels this time? This cancels. What's left? 3 times 2 is 6. You see? This is actually a way to make things easier. Even though you might think that we're making it difficult, we're actually finding a way to take something that is difficult to solve in a difficult form called the radical equation and making it easier. You're either going to end up with a linear equation or a quadratic equation. Okay? All right. So now, what do I do? Well, if I move the 6 to the other side, they're going to cancel. Okay? So what's left? We'll divide this by -9. What's left? This. Look what I get. X equals 6. Now, at this point, you may claim victory, but you will be wrong because from the beginning, it was stated that y cannot be equal to 6. So in this case, even though you end up with y equals 6, your solution would be no solution. Okay? Or sometimes they write the empty set. The set where the solution typically goes, inside there's nothing. It's empty set. Or in ALEKS will give you the option to say no solution. Again, the reason why you have no solution is because from the beginning, it was established that y cannot be equal to 6. And even though you get 6 at the end, that doesn't make it right. Okay, so in this case, you did all this work to find out that this problem has no solution. That's what that means. Okay. All right. So I'm gonna end it here, guys. Good luck to you on Thursday, and I'll see you soon. Okay. On for test 3. All right. I'm gonna start the recording now.